Now let's talk about excuse me, the different reflexes that are mediated by the spinal cord. So they are called as spinal reflexes. The first is a stress reflex. In the form of stretch reflex, you have something called as knee jerk reflex. So this is pretty common when you go to a neurologist office, where he or she would tap the your knee tendon and your knee automatically stretches forward. So it involves tapping of tendon with a brief stretch of muscle, and that activates the spindle sensory endings. The spindle efferents to alpha motor neuron, and there is delayed contraction of the stretched muscle. So this is how it works basically. Um, Next, you have the withdrawal or the flexor reflex, which is basically happens when you touch a painful stimulus. For example, a needle, or you get pricked by something and you want to withdraw your finger from that stimulus, which causes the pain. That's basically because of the pain receptors in the skin. They pick up that painful stimulus, and it that afferent information is passed down to spinal cord. And then there is activation of interneurons and alpha motor neurons, and of course there's contraction of the associated muscles. So this is an example, a schematic representation of how a withdrawal reflex works. Next is the crossed extensor reflex, which is withdrawal on one side accompanied by extension of opposite limb. So it's a protective reflex for moving the entire body away. So you not only withdraw on one side, and it is also accompanied by extension of the opposite limb. So here you withdraw, and then it this oops, sorry, this limb extends. And other than reflexes, the other part, the spinal cord is responsible is by innervating the muscles of respiration through the phrenic nerve, and it sets a pattern cycle of inhalation and exhalation basically. So we talked about the motor unit. So one of the important components of the motor unit is actually the nerve and the muscle it innervates, and the information from the nerve is passed on to the muscle through the neurotransmitters. Acetylcholine is a major neurotransmitter that is involved with regulating voluntary or reflexive motor movement and autonomic functions. So when this ACH neurotransmitter is reduced, it results in a disease called as myasthenia gravis. I think we talked about it in class, but it's called as progressive weakening with use. So what happens is when people with myasthenia gravis, they run out of acetylcholine neurotransmitter once they start moving their muscle. So when they are involved in a motor activity, they start becoming tired after a while because of the depletion of ACH neurotransmitter. However, if they rest for a brief period of time and continue doing the activity again, they are fine. But again, after some time, they do get tired out. So this is called as progressive weakness with use. The other transmitter also which is involved in the spinal cord movement regulation is the epinephrine and norepinephrine and serotonin, but the most important neurotransmitter is the ACH. So what happens when spinal cord is damaged? Of course, it the motor movement is compromised, but definitely the muscle strength is affected. The reflexes are altered. They either become hyperactive, and then people have something called as clonus, which is repetitive involuntary movements. It's more like tremors. And there are two types of spinal cord disorder. One is segmental, which is at the specific spinal level. For example, if the thoracic vertebrae T7 is responsible for it, let's say example, regulating breathing, and then if T7 is damaged, then the breathing is affected. Or it can be longitudinal damage with this pathway specific. For example, we know fasciculus, cuneatus, and gracilis are the ascending motor sensory tracts. So either the whole pathway can be affected, or it can be just a segment of the spinal cord. One of the common problems seen in people with spinal cord lesion is called as the element syndrome. Element stands for lower motor neurons. So of course, it involves problems with motor execution. So the motor neuron and its axon is affected. There can be nerve denervation, which means the nerve do not receive the neural impulses. There can be loss of muscle power, reduced reflexes. So if the muscles don't receive neural impulses, that's their foot, so they shrink in size, and that's called as atrophy. And of course, it can lead to flaccid paralysis. So this is an example of low element syndrome. So you know the efferent, the alpha motor neuron is affected. So that can cause all these problems, which are the typical characteristics of element syndrome. Other bacterial infection which can lead to element problem is poliomyelitis, which myelitis is the inflammation of the myelin sheath, and it's caused by microorganism. But I think right now polio is completely unheard of. Um, and also ALS, vascular damage, which means reduction in blood supply, and spinal cord tumor can give rise to element syndrome. There can also be a small lesion or large lesion that can give rise to element syndrome. And there can be a complete spinal transection, which means taking off the spinal cord. For example, in case of vertebral dislocation, myelitis, and tumors. So that results in bilateral loss of sensory and motor functions below and spared above the lesion. So wherever you take off the spinal cord, so anything below that site of lesion is compromised, but the functions that are mediated by the part of the spinal cord above the lesion is spared. Um, so this is an example of where all the parts of the spinal cord are affected. So if there is a complete spinal section at T12, you can see the part of the spinal cord below T12 mediates reflect motor movements in the lower half of the body that's affected. And however, the part of the spinal cord that is above T12 mediates movements in the upper half of the body, and that's relatively spared. And then you have something called as Brown Sequard syndrome. That's basically spinal hemisection. So a part of the spinal cord is compromised. So the characteristics would be ipsilateral loss of movement. So the part of the spinal cord on that side of the body is compromised. The sensation is compromised, and there is gonna be problems with the pain and temperature perception as well. So this is an example of the Brown-Sequard syndrome where this part of the spinal cord is affected. So you can see there is upper motor neuron monoplegia, loss of discriminatory touch, loss of pain and temperature as well. And then you have other anatomical problems, which is called as syringomyelia, which is a cyst or cavity within the central spinal region. So that results in bilateral loss of pain and temperature sensation because the ascending spinal tracts, the cuneus and gracilis, are affected, and there is also bilateral paralysis in selected muscles. So that's about the spinal cord chapter. I think the important part is from your exam, a detailed question can. There's more chances that you have to answer about the neuromotor control, where you need to know about how the change in length is picked up by the intrafusal muscle fibers, thanks to the annulospiral endings that are wrapped around the intrafusal muscle fibers, and that information is passed on through the gamma motor neurons to the interneuron that connects the gamma and the alpha motor neurons. The interneuron talks to alpha motor neurons, and the alpha motor neurons realizes that there is a change in the muscle length, and then it has to contract and it has to innervate the extrafusal muscle fibers so that they contract and accommodate the change. So that's something you need to talk about for sure. And we will again talk about this on Tuesday. But if there are any questions, please come prepared and we'll talk about it on Tuesday. Thank you.